Welcome to Chemistry Academy, Fajandar High School and Junior College, Wahoo. Dear student, now in last videos, so far we have discussed related to halogen derivatives. First point was introduction, classification of halogen derivatives in different manners, then how to write the common system, IUPAC nomenclature of halogen derivatives, that is haloalkane as well as aryl halides, that is aromatic halides. Okay, now then we have discussed the preparation methods of alkyl halides. First one, direct halogenation. We have avoided. Our first method was hydrohalogenation of unsaturated hydrocarbon, Markovnikov rule, anti-Markovnikov rule, Kharash effect, then halogen exchange method, then by using alcohol and phosphorus halides, PCl3, PCl5, then by using alcohol and thionyl chloride. Now our last preparation method and related to aryl halides, preparation of aryl halides, or we can say aromatic halides, aromatic compounds like chlorobenzene, bromobenzene, iodobenzene. Okay, now for preparation of aryl halides, our method is electrophilic substitution reaction. Now substitution we know, replacement. One atom or group of atom is replaced by or substituted by another atom or group of atom. That is called as substitution reaction. Now electrophilic, actually these are the reagents. Now in 11th standard, two types of reagents we have discussed. One is your nucleophile or nucleophilic reagent, and second one was electrophile or electrophilic reagent. Now what are the nucleophile? किसको बोलूंगा मैं nucleophile? What are the electrophiles? Now nucleophile means we can say nucleus loving species. Nucleus loving means that are the electron rich species. Electrophiles are electron deficient. Electrophiles are electron loving species, or it is electron deficient species. Okay, so that is the difference between nucleophile and electrophile. Our method, electrophilic substitution reaction. Now aromatic compound benzene or its derivative easily undergoes electrophilic substitution reaction. Means in this reaction, H of benzene, when we will see this reaction, H of benzene, it is replaced by a suitable electrophile like Br. Okay, we can say Cl, then SO3H, we can say NO2. Okay, so H of benzene or its derivative is replaced by electrophiles like Br, Cl, SO3H means we can say sulfonic acid, NO2 means nitro group. Okay, so this reaction is called as electrophilic substitution reaction. Now benzene easily undergoes electrophilic substitution reaction either at ordinary temperature, means room temperature, or we can say in dark. Easily undergoes electrophilic substitution reaction. Why benzene easily undergoes electrophilic as compared to nucleophilic substitution reaction? That all parts we will try to cover in next videos. Okay, now our method, preparation of aromatic halides, that is aryl halides by electrophilic substitution reaction. Now I am writing here one example. Suppose benzene is given to you. Student, see, this one is your benzene. Benzene react with chlorine in presence of Fe, act as a catalyst, and the arrow condition is given dark, Fe in dark. Okay, now in case of benzene there are 6 carbon atoms, and at each position one hydrogen atom is there. So the molecular formula of benzene is C6H6, or we can draw this structure like. Okay, now both are the structure of benzene. Okay, at each position hydrogen atom is attached, so the molecular formula of benzene is C6H6. C6H6. When benzene react with chlorine, we can write here Cl. When chlorine will break, it gives positive charge species, and positive charge species are called as a electrophile. In this case, one of the hydrogen atom from any position, one of the hydrogen atom and Cl, there is a removal of HCl. One of the hydrogen atom from benzene and Cl, there is a removal of HCl, or we can say this remaining Cl attached to this carbon, and we will get the product like this. Now see, this one is my benzene. When you will observe the structure, now this one is also benzene, but what is the basic difference of this benzene ring? So we can say one H is replaced by Cl, and this is called as electrophilic substitution reaction. Now what is the aim to show this reaction? ये रिएक्शन शो करने का मकसद क्या है? ट्राई टू रिमेम्बर, इन केस ऑफ बेंजीन एट ईच पोजीशन और हर कार्बन पर एक हाइड्रोजन एटम अटैच्ड है, और वो हाइड्रोजन एटम रिप्लेस होता, सब्स्टिट्यूट होता. नाउ दिस रिएक्शन आई एम राइटिंग हियर. नाउ दिस वन इज योर बेंजीन. फ्रॉम एनी कार्बन हाइड्रोजन एटम इज रिप्लेस्ड, so this benzene will convert into chlorobenzene. Benzene will convert into chlorobenzene, and my byproduct is HCl, and this reaction is called as electrophilic substitution reaction. Okay, student, so this is the method which is given to us, preparation of aromatic halides or aryl halides by electrophilic substitution reaction. Now in this case, instead of Cl2, if Br2 is given to you, arrow condition is AlBr3, aluminium tribromide, which is a catalyst, or we can say Lewis acid. So here we will get bromobenzene. Cl की जगह मैं क्या लिखूंगा? Br. Okay. Now suppose next one is given toluene. Instead of benzene, a substituted benzene or derivative of benzene is given. Now it is called as toluene. This reagent is called as a toluene, and toluene react with bromine Br2 in dark or in presence of Lewis acid AlBr3, aluminium tribromide, or it acts as a catalyst which increase the rate of the reaction. Now in this case, what would be my expected product? Here toluene react with bromine. Actually when substituted benzene is given, so the substituent जो ग्रुप बेंजीन को अटैच्ड है, सब्स्टिट्यूएंट मतलब जो ग्रुप बेंजीन को अटैच्ड है, उसका रोल बहुत इंपॉर्टेंट रहता है, वेदर इट इज ऑर्थो पैरा डीएक्टिवेटिंग ग्रुप और मेटा डीएक्टिवेटिंग ग्रुप. अब ऑर्थो पैरा एंड मेटा मतलब ये ग्रुप रहने की वजह से अपने 11 में स्टडी किए, प्लस आई इफेक्ट माइनस आई इफेक्ट प्लस आर इफेक्ट माइनस आर इफेक्ट, positive resonance effect, negative resonance effect, positive inductive effect, negative inductive effect. Now some groups are capable to donate the electron towards the benzene ring, and some are capable to withdraw the electron from benzene ring. अब अगर कुछ species electron donate कर रहा benzene ring को, so in case of resonating structure, the negative charges will be at ortho and पैरा पोजिशन. वो रेजोनेटिंग स्ट्रक्चर आप लोगों ने 11 में कवर किया. राइट द रेजोनेटिंग स्ट्रक्चर ऑफ टोलुइन, अल्कोहल लाइक फेनॉल, देन एनिलीन. इन सच केसेस नेगेटिव चार्ज कैरीड एट कार्बन नंबर 2, 4 and 6 means ortho, para and ortho. So these groups are the ऑर्थो पैरा डायरेक्टिंग और डीएक्टिवेटिंग ग्रुप. मतलब जो इनकमिंग ग्रुप आएगा वो कहां पर आएगा? एक तो ऑर्थो पोजीशन पर आएगा या कौन सी पोजीशन पर आएगा? पैरा पोजीशन पर, एंड दैट इज कॉल्ड एज ऑर्थो पैरा डीएक्टिवेटिंग ग्रुप. क्या बोलते हैं इनको? ऑर्थो पैरा डीएक्टिवेटिंग ग्रुप. नाउ फॉर बैलेंसिंग पर्पस वी विल टेक हियर टू एरोमेटिक कंपाउंड लाइक टोलुएन 2Br2, and here we will get two product. Now in one case the incoming group, अब incoming group मतलब Br attached to ortho position, and in second case incoming group attached to para position, and here we will get two product, and byproduct is twice of HBr. Now one hydrogen atom from ortho position of one toluene and second hydrogen atom from para position of second toluene. I am not writing separately. I have written here 2. Okay, so एक टोल्यूइन का ऑर्थो पोजीशन का H सब्स्टिट्यूट होगा और दूसरे टोल्यूइन का कौन सा पोजीशन का H सब्स्टिट्यूट होगा, पैरा पोजीशन का. नाउ दिस इज कॉल्ड एज ऑर्थो ब्रोमोटोल्यूइन या 2 ब्रोमोटोल्यूइन एंड दिस वन इज योर पैरा ब्रोमोटोल्यूइन और इट इज कॉल्ड एज 4 ब्रोमोटोल्यूइन एंड दिस वन इज योर लास्ट प्रिपरेशन मेथड ऑफ halogen derivatives like aryl halides. Now student, in this case we can't prepare a fluorobenzene because it is highly explosive, highly reactive. Fluorine amongst all halogen atom, fluorine is highly reactive, so we can't prepare a fluorobenzene. Now suppose I have to prepare the iodobenzene, means instead of Cl and Br I have to attach here I. So direct iodination is not possible. Like here, suppose I am writing benzene ring. Suppose I am writing benzene ring. See, this one is my benzene plus I2 in presence of dark or at room temperature. For example, in presence of dark or at room temperature, no doubt one H replaced by I means here we will get iodobenzene plus Hi. No doubt, iodobenzene plus Hi. But due to the high reactivity of Hi, the reaction will not stop there. This Hi back react with iodobenzene and reaction will be reversible. मतलब ये Hi क्या करेगा, iodobenzene से react करेगा and now this 2I combine together and it form I2 and we will get back aromatic compound benzene. Means reaction will not complete, the reaction will be reversible and that's why direct iodination is not possible. If direct iodination is not possible, then how to perform the iodination of aromatic compound? कैसा perform करूंगा मैं iodination of aromatic compound? So for that purpose, student, we have to use a suitable oxidizing agent like nitric acid HNO3 or iodic acid HiO4. Now this nitric acid and iodic acid, nitric acid and iodic, nitric acid means HNO3, iodic acid means HiO4. These are the oxidizing agent. Now what is the role of this oxidizing agent? Means when the reaction will be complete, this oxidizing agent remove Hi. ये ऑक्सीडाइजिंग एजेंट क्या करता है, Hi को रिमूव कर देता है. अब अगर Hi को रिमूव किया, नो रिवर्सिबल रिएक्शन इज पॉसिबल, नो रिवर्सिबल रिएक्शन इज पॉसिबल. इक्विलिब्रियम विल शिफ्ट टुवर्ड्स द राइट. अब इक्विलिब्रियम विल शिफ्ट टुवर्ड्स द राइट मींस प्रोडक्ट विल फॉर्म एंड रिएक्शन विल स्टॉप, क्योंकि यहां से ये क्या करता है, Hi को रिमूव कर देता. अब अगर Hi को रिमूव कर रहा, सो दिस Hi विल रिएक्ट विथ I? नो. So try to remember, this is your important concept. Direct iodination of benzene is not possible. And why direct iodination of benzene is not possible? क्यों direct iodination of benzene नहीं होगा? Because a reversible reaction will take place. So this iodination take place in presence of oxidizing agent like nitric acid and periodic acid. Okay, so this is your last preparation method of halogen derivatives, that is aryl halides or aromatic compounds. Now in this case one reaction is also given, that is Sandmeyer's reaction, but it is omitted. That part is deleted in our syllabus for this year, for current 2020-2021. So student, note down all these reactions, try to remember electrophiles and nucleophile. Just go through some basic concept of organic chemistry. 11th standard उसमें ये दिया हुआ है, electron rich species, electron deficient species, nucleus loving species, electron loving species. One is electrophile, another one is your nucleophile. Then try to remember the resonating structure. Why incoming group? अब यहाँ incoming group कौन सा है, Br. incoming group at ortho and para position, why it is at meta position, वो सब पार्ट आपने 11 में कवर किए. We have written that a lot of resonating structure. Just go through that resonating structure and try to remember. Okay, so this is our last preparation method, that is preparation of aryl halides. Hope आपको समझ में आया होगा. Now in next video lecture we will try to cover one of the important concept of halogen derivatives, that is physical properties, most important concept. And now in physical properties we will try to cover the melting point, boiling point, solubility, and some examples on some questions. Hope you understand this part. Okay, thank you.